Hey there, Jack Delora here. In this video, we're going to continue with our TouchDesigner and monome norns series of videos by taking our previously modified awake script, which we added OSC to in the last video in the series, adding a couple more features to it, and then creating this visual effect in TouchDesigner, which is inspired by the awake sequencer graphic that you see on the norns display. Our main focus here is going to be working with geometry instancing, which is a super fun and interesting technique within the realm of TouchDesigner. So this will be a great example for anyone interested in starting to trigger animations that are created with instancing effects. We're going to start off this project in Maiden. Head to norns.local in the browser of your choice, and then make sure that you've installed the awake script. I'm then going to head to the code folder, then to awake, and then within that folder, by default, you'll just have the awake.lua file as well as the lib folder. Now, I have some additional stuff from both creating this project and the last one, but we're going to create a new file here so that we can save our changes separately from the main Lua script. So I'm going to click once on one of the files within this folder, then I'll hit the plus icon here, and then I've got this new untitled.lua file. I'll click on that once, and then click the pencil to rename that file. Now I'm going to call this awake plus OSC underscore study 2, because this is the second in this series, and then because I already have a file with that name, I'm going to add slash rec for recording at the end, but feel free to really to name yours whatever you like. Once you've picked a name, hit the check, and then make sure to hit the floppy disk icon to save the script. What we'll do to start is to head to the default awake.lua file. I'm going to Control A, Control C to select everything and copy it, and I'm going to paste that into the new file I've just created. I'll then save that file, and we can start adding in our changes. So we'll start off by creating a variable. This is going to be called td_dest for destination. This is going to be the IP address and port that we will eventually be sending OSC messages to. I'll set this equal to a table, which will be some curly braces, and these again are going to contain the IP address that I want to send the messages to and the port that I want to use as well. In the last video, we looked at a convenient feature of the OSC operators in TouchDesigner, and we'll use those to get the local address of the current machine that I'm using. So I've opened up TouchDesigner and added the OSC in chop to the network. This is what we'll be using later on in this video. Once I've added it to the network, I can then come to the parameters window, and we'll see that we have this local address parameter. And then if we mouse over to this arrow on the right and click it, this top IP address is my current machine that I'm using on my local network. So I'm going to write this down and utilize this in the code back in Maiden. So back in Maiden, I'm going to add some double quotes and enter in my IP address, which was 192.168.0.189. Then we're going to specify a port, which is going to be 10101. This will be something that we set up in TouchDesigner to have our TouchDesigner project be expecting messages on this port, so we can really set it to whatever we want, but we have to make sure that the port that we set here in the code matches what we have in TouchDesigner. I'll then save my code and we can carry on. Next, we're going to scroll down through this code until we find the step function. The step function is what drives the functionality of the step sequencer. So we've got things like controlling our audio engine, sending MIDI, etc. And we're going to add a line of code right after this line here, 162 in my case, if math.random in quotes 100 is less than or equal to params dot or params colon get probability, then we're going to add a couple of new lines here, and we're going to send the note number, which is a variable that's been set up already, the current note number of that step in the sequence. We're going to send that via OSC to TouchDesigner. So I'm going to type in osc.send. And the first thing I'm going to need to do is to provide my destination. So this is the table that we set up earlier, so td_dest. Then I need to provide an address. So this is something that I'm going to define here. I'm going to call this /note, which is just to differentiate it from the other data that we're going to be sending, and also because, of course, this is going to provide the current steps note number. After that, we need to provide our arguments. This is like the data that goes along with the message, the important information that we want to be able to send. This is a table once again, so I'm going to add my curly braces, and then I'm just going to send simply note_num, which again is that variable that's previously set up containing the note value. All right, so let's move on to the next line where we're going to send another OSC message. So osc.send, open and close parentheses. Again, we need to provide the destination, so we'll use that again. This time we're going to be sending the position within our sequence of the current step. So I'm going to provide a new name here for the address, which is going to be POS for position. And we're going to be sending along the position within the top sequence if we're thinking of the awake user interface, which is defining the basic pitches of our sequence, which then have some transposition and things like that applied via the bottom sequence. So what we need to provide here in our table at the end as our data comes from this section. Well, you can see it's used in this portion above, which is the one.pos variable, and that is going to provide the position within that top sequence. Now, if you wanted to, you could also add in a second, or actually even a third OSC message at this point, and provide the current position in the second sequence by using and sending along the to.pos variable that we see up top. You could even send those in perhaps as a two-element table if we wanted to. For this project, we're just going to be using the position within the first sequence, so that's all I'm going to do at this point. I'll then save, and then we can move on. Now, one other thing that'd be handy to know about our sequence on the TouchDesigner end and be able to utilize is the current length of the sequence. This is something that, as you're working with the awake script, you can adjust in real time, and will change the output of the sequence. And so by being able to utilize that within TouchDesigner and know when those changes occur, we can take that into account in the visualization that we create at the end. So I'm going to add another line after this if statement on 156 for me. That starts with if 2.pos or position is greater than 2.length, etc. I'm going to add some new lines and then send osc.send, again, accessing the same td.destination. Then for the data that we're going to send over, we're going to be sending the length of that first sequence. So you can see here we can access the length attribute of that sequence by typing in one.length. So that's what I'll add here within curly braces. And just like the previous OSC message that we were sending, you could also send over the length of the second sequence if you so choose. So with that in mind, I'm just going to add in some notes to myself, reminding me what these are going to be used for, what they're doing, and then I will save and head over to TouchDesigner. All right, with some notes added to remind myself what I'm doing with these steps that I've added into the code, I'm going to save and head over to TouchDesigner. All right, now that I'm in TouchDesigner, I'm going to do a quick test of the connectivity between the norns and TouchDesigner just to make sure that everything is functioning. So while I'm doing this on my norns device, I'm going to open up the script that I've just saved and get that running in the background. And then over here in TouchDesigner, I've already got the OSC in chop added to the network. So if you haven't done so already, start up a fresh project in TouchDesigner, add the OSC in chop to your network, and then we can go from there. First up, I'm going to change the network port here. So this, remember from our code, is 10101. I'll hit enter. And we can see immediately, thankfully, we have the OSC messages from the norns coming right in. So I'm going to add a null to this OSC in chop. This is going to be my main point of access for the OSC data. So I'm going to give it a name to help me remember that. I'm going to call this null underscore OSC underscore data. And there we go. For this project, we're going to be using a very cool chop called the event chop. The event chop, as we can see here in the op create dialog, manages the birth and life of overlapping events triggered by devices like a MIDI keyboard. So this is a common tool that is utilized with things like notes coming from a MIDI device or a sequencer, etc. In that we can create these separate events with things like an ADSR envelope attached to them. And that's what we're going to do today for creating this visualization. So there are actually a number of ways that this can be triggered. And the way that we're going to do things today is to, instead of using the chop data directly to trigger this event chop to create a new event, we're going to use a chop execute dat to use Python code to trigger the creation of a new event instead. And there's a very beneficial reason for doing so that we'll look at in just a moment. So that means we're going to need to add the chop execute dat to the network. So I'm going to open up the op create dialog, head to the dat page, and then grab the chop execute dat. With that added to the network, I first need to provide a chop with which to trigger this functionality with, and that is going to be my null OSC data chop from before. So I'm going to drag that onto the chops parameter. The particular functionality or function definition that I want to use in this case is the value change option, and this is going to trigger anytime one of these channels of data changes. Next up, let's open this in an external code editor by hitting Control E. Great, so we're going to be working exclusively within this onValueChange function. So what I want to do is to trigger the creation of a new event every time this position value changes. So within this onValueChange function, I'm going to use an if statement to parse out the names of the channels here and select the one that I want, which is going to be POS. So if the channel.name equals single quotes POS, then we're going to create an event using the event1 chop that I just added to the network. So we need to access that by typing in op, open and close parentheses, single quotes, event1, and then I need to use the method that goes along with that called create capital E event. This allows me to create an event without, again, having to connect directly to that operator. And we'll take a look at the documentation in a moment just so you can see what other options you have for modifying how this event. We'll take a look at the documentation in a second so you can see the other options that you have when creating an event this way. All that I care about for this example is that we are going to be able to set our index value, which is one of the many channels of information that we have available in the event chop. I want to be able to set that value to the current step or position that we're receiving via this POS channel. So to do that, I'm going to type in index within the parentheses there, and I'm going to set that equal to val, which is the current evaluated value of the channel that has just changed. From there, I'm going to hit Control S to save the code. And if we click back over to TouchDesigner, we should see that immediately we have some events being created. Also important to note here is if we look at this index channel, that is being modified and changed by this position value. So effectively, we now have the ability to connect, if we're thinking about taking a single slice, a single sample out of this chop channel, we can also know which step within our sequence that is occurring on. All right, so we've got some additional work to do with this event chop now. The first thing that I want to do is to be able to utilize the third input here, which is the sample input. And this allows us to, every time that we create a new event, to take a sample from whatever chop we've connected to it, and then that is reproduced along with all of these other channels of information. So for this example, I'm going to be using the select chop to grab one of the channels from this OSC data operator. And what I'll do here is I'm going to type in for the name select OSC data. We're going to be doing this a lot, so I'm just going to name it now to make things a little bit easier. And then I'm going to click and drag this null OSC data operator onto the select OSC data operator. Now here, I only need the note channel specifically. So I'm going to come up to the channel names parameter and then click the arrow on the right and then click note. So we've isolated that channel, and then I can connect that to the sample input, the third one here. And we'll notice that we now have a new channel added into the mix, which is called note. And that is, again, for every sample within this series of chop channels, we have the note number being recorded as well. So we now can trace for each data point in this graph, the index, the position within the sequence, and the note value for that position as well. Having done that, let's click on the event chop itself and make some changes. We're going to be working exclusively on the ADSR page. So first off, I'm going to set this attack time to 0. We're going to leave the attack level alone. The decay time, we're going to turn up to a value of 2. So I'm going to use the value ladder here. I'm going to middle mouse click on this one value. And then while I'm still holding that middle mouse button, I'm going to move up to the 1 digit and then move the mouse to the right, which allows me to increase that value. Then for the sustain time, I'm going to use the value ladder again and take that down to 0. Could also just use the slider. And then for the sustain minimum and maximum, I'm also going to set those to 0. Finally, I'm going to set this release time to a value of 1. And that is going to be it for this operator. So with that, I've changed the ADSR envelope associated with each one of these triggered events that we're creating. And that will come into play in a more visible way once we start generating some visual content from it. But this is something we can come back to and experiment with later. Before we move on, I wanted to point out again that we can access the Python help for any operator to find out more information about it. And as we just used the .createEvent function for the event chop, it's also helpful to know what you can do with that function. So we're going to click on the second question mark icon in the parameter window. This is going to bring up my web browser again. And you'll see here that we've got some members, if that particular operator has any members, and some methods as well. So for this operator, again, we have the create event function, which we already know about since we just used that, but it has a variety of arguments which we can supply along with that function call as well. And so we'll see here that we can really modify per event that we're creating a lot more than just the index value. We can really change that entire ADSR envelope based on whatever parameters we set up. So I just wanted to point that out so that you have an option to, get a little bit more creative with how you are triggering these events. With that, let's head back to TouchDesigner, and we're going to continue by adding a null to the end of the event chop. So again, I'm going to use Alt-N on the keyboard, and this is going to be my null space event null chop, where I access the information that's been created by the event chop. Now with this small amount of data generated already, we can actually start our process of visualizing this and creating this visual component of our project. We haven't really talked a whole lot about that yet. This is going to be done with 3D rendering and a really cool technique called instancing. So we're going to start off with the box SOP. This is going to be the main visual element of each step of our sequence. So for this, I'm going to modify the scale a little bit here. I'm going to set the size parameter in the y-axis, which remember is vertical in TouchDesigner, to a value of 0.2. Then I'm going to take this scale parameter, which will scale uniformly across all axes. I'm going to set this to 0.2 to further reduce the scale of the box as a whole. Then I'm going to connect this to a geometry comp. And we're going to do this by right-clicking on the output of the box SOP, heading to the comp page, and then grabbing the geometry comp. So we can see our box is appearing within that geometry comp. Let's go ahead and set up the rest of our rendering pipeline right now so that we can start to see the output of the project. I'm going to add in a camera, and I'm also going to add in a light. Then I'll add in a material on the matte page, which is going to be the Fong material in this case, since we do want a little bit of shading based on this light. I need to assign this Fong to the geo, so I'm going to click and drag it onto the geo, and then let go of the left mouse button and click the parameter material option that comes up in this dialog. Now I can add a render top to the network, and it will automatically grab all of those things and create a texture with the rendered output from the camera. And we can see we have one block sitting right at the center of our render. So next up, we're going to work with instancing. This allows us to create many copies of this geometry within our geocomp without too much of a performance hit. We can access and modify the attributes of these additional instances of this geometry that we're adding, including things like the position, the scale, let's say the color that's applied to them, and animate those parameters as well. So to start instancing, we're going to click on the geocomp and head to the instance page. You'll see here that we have a switch here for instancing, which is currently off. I'm going to click on that to turn it on. And then we need to provide an operator for one of the many attributes that we can control to start generating instances. So in this case, we're going to be using the null event chop for a couple of things here, and those are going to be actually basically the scale parameter. Okay. In this case, we're going to be using the null event chop for the scaling of the different instances that we're going to generate. And so I can simply drag the null event chop onto this scale op parameter. And then for the scale of the instances that we'll be generating, I'm going to use the ADSR channel. So to access that quickly, again, we can use this rightward facing arrow, and I'm going to grab the ADSR channel for scale X, Y, and Z. So what's happening? We can see that we have this kind of pulsing animation appearing on our geocomp. But what has happened is that we actually now have anywhere from, well, it looks like we're kind of oscillating between 15 and 16 different copies of that geometry, which are all being placed on top of one another because we are not modifying the position of them at all yet. However, we are modifying the scale, and that's why we're seeing this small amount of animation changing. And because it's attached to the ADSR envelope, it will have this kind of fast attack, a little bit slower decay kind of envelope to the scale that's being changed. An important thing to know about instancing is that the amount of instances that we will be generating at any given point will be controlled in different ways depending on what kind of operator you're using to supply the instance data. So if we're talking about a chop here, like we have here with the null event chop, for each sample, this is a multi-sample chop, so we've got for each channel of information, we have roughly 15, 16, or 17, depending on the moment, different data points essentially, or slices of this x-axis at the bottom. And for each sample of information inside of a chop, that's going to define or be applied to one instance above. So that's why I was able to click on this with the middle mouse button and know that because we have roughly 15 to 17 samples at any given point, we're going to have the same number of instances. However, if we were working with something like a SOP operator for providing some additional instancing information, which we can do, the attribute of a SOP that's going to be used to define instances is the number of points. Likewise, if we're talking about a top texture, we're going to be generating one instance per pixel. In all of these situations, another important thing to know is that the number of instances that we're generating when we start to have multiple different operators providing different attributes for instancing, the number of instances that are being generated have to be the same. So if we have another chop that we're going to be generating some attributes of these instances with, it has to have the exact same number of samples as this null event chop here. If we were generating SOPs, we would have to have the same number of points, and if we were working with textures, we would have to have the same number of pixels. These things will kind of become more intuitive with practice, but it's important to point them out now so that you don't end up in a situation where you are scratching your head because of the errors that you might receive if you try to use a combination of different operators. With that in mind, let's move on to creating some positional values for each one of these instances. I'm going to add some select chops to the network, and I'm going to need 2 of these for X and Y positioning. So I'll copy and paste the first one that I've added there. And actually for both of these operators, we're going to be accessing the null event chop. So I'm going to go ahead and right click and drag to box select them together. And then in the parameter window on the right, I'm going to click and drag the null event chop onto the chops parameter. For the first select up here, I'm going to be selecting the index. So I'm going to come up to the channel names parameter and set this to index. And then I'm going to rename this to X because I'm going to use this in the end for my X position information. So for the select number 2, this is going to be pulling in my note value. And so we're going to use the note value essentially to adjust the Y position. The X position is the current position in the sequence. So again, for the second select here, we're going to pull in the note channel of information. We'll rename that to Y. Now I'm going to rename the select chops here to remind myself where that data is coming from. So this first one here, this is going to be selecting the index. So select space index, and then this one is our note number, so select note. From there, I'm going to use the math chop to change the output range of these very slightly. In this first one here, I'm going to head to the range page, and this is where we're going to make our changes. So we have the ability to adjust our output range provided that we give the input range of the values that this will receive. So what I'm going to do here is to synchronize the maximum to this from range to the length of our sequence at the current moment. So basically it'll be flexible when we have more or less notes in the sequence, again, based on the parameters we can adjust in the awake script. This will correspondingly make the changes needed to ensure that the output range stays the same. So to do that, to connect this upper boundary parameter to this length channel, I can simply make a chop reference. So I'm going to click on the viewer active switch of the null OSC data operator, and I'm going to click and drag on the length channel and then keep holding my mouse down and let it go over this one parameter in the from range. So that's the upper limit there. I'm going to let go. It's going to bring up a new dialog here, and I'm going to click chop reference. If we click the title here to bring up this dropdown, we can see that we've got the same op function here to access this operator, and then within brackets we can access the channel of a chop by providing the name of the channel in string format or an index value instead. Anyway, that's made the connection maybe a little bit faster for us than having to type all that out. And I know that the way things work when it comes to this length parameter is that we can't have a length of 0, so my input range will never be lower than a value of 1. In the output range, I'm essentially setting the left and right boundaries of the positions of our different boxes here in space. And so I found that an output range of -1.7 to +1.7 worked pretty well given the space we have in our output render. Now we're not going to see anything yet because we haven't connected this to our instancing setup, and that's okay. But we've got that prepped and ready to go. Now I'm going to do the same thing with the Y position output. I'm going to use a math chop again to manipulate the output range. Now in this case, because I haven't set things up to be smart and sort of adjust on their own, we're going to be manually setting the from range. And but now that you've kind of seen how we can start to programmatically connect things together, you could do the same sort of situation here. What I've discovered through experimentation with this script is that if we're working in the default, I think it's C3 root note, and then utilizing the default scale, we can have a range of notes in this sequence from note number 60 to note number 86. And so that's my upper and lower and upper boundaries for the input data. And then for the output range that I want, I'm going to set this to fall between -1 and 1. Now, again, if you wanted to, you could set something up where perhaps the OSC messages also send over the root note of the scale and maybe the particular scale that you're using, and then calculate what the maximum note value might be. But just to keep things a little bit simpler and not take even longer to put this together, I decided to keep it simple. We need to now take these two channels of information and merge them into a single chop operator. So I'm going to add a merge chop to the network, and then I'll box select both math 1 and 2, and then click from the output of one of those and drag to connect them both to the merge at the same time. Finally, I'm going to add a null to the end. And this is going to be called null translate because this provides the X and Y translation parameters of the instances. Now let's go ahead and click on the GO1 again. I'm going to drag null translate onto the translate op parameter, and then I will use the X channel for translate X and the Y channel for translate Y. We should see immediately that we've got a different output now. Things are looking a little bit more interesting. We've got, again, movement in the X and Y direction, as well as some scaling going on here. So they're shrinking in size over time after the event has been generated. And we can continue on by adding some more complexity to this effect. For the next section, we're going to be adding color to our instances. So we're going to start off and build this out down here below our previous set of chops. We're going to start off again with a select chop. And in this case, we're going to be using the Y position, the final Y position, to define the color that we are applying to our instance, which basically means that a lower note value will have a different color than a higher note value, and we can kind of judge the kind of pitch of the note roughly based on the colors that we set for that kind of maximum and minimum. So I'm going to use the select chop here to access the null translate operator. So I'm going to drag that into the chops parameter. And then again, I only need the Y position value, so I'm just going to use the channel names parameter here to grab the Y channel. I'll then say select translate Y for the name of this, again, so I remember where that's coming from, and then we can move right along. I'm going to use a top actually to define the colors that will be applied to this kind of gradient of pitch values that we'll be getting. And we're going to be applying a gradient to those values via the ramp top. So the ramp top is a great tool for making ramps, which can be simple gradients like this, or can be radial gradients, circular gradients, etc. So let's go ahead and set up some colors in this gradient, change things up from the default look. For the left color keyframe, I'm going to click on this little rectangle here on the left side of our color keyframe selector, and for this one here, I'm going to change it to a dark blue color. So I'm going to start by bringing my saturation and value sliders up, and then move this hue slider over into the blue range. Next up, I'm going to add a color keyframe in the middle of this ramp by left clicking, and then I'm going to set this to a yellow color, and then maybe increase the saturation there as well. Finally, I'm going to click on the right color keyframe, and I'm going to shift this to this kind of turquoise color, and again move the saturation here up to a higher value. I might then think about shifting the yellow more into the center, and of course feel free to add any color you like here. You don't have to use what I'm using for this demo. Another thing to point out is if you accidentally add a color keyframe that you don't want, all you have to do is left click on that color keyframe, keep holding until you have dragged off of this keyframe selector, and it will disappear. That's how we add by left clicking, and we delete by left clicking and dragging off. With that complete, I'm going to use a handy operator to convert this texture into chop channel information. So I'm going to go to the chop page and grab the top two operator. I don't need to do anything over here in this operator, but we're going to move on to our next operator instead. So we have a handy operator called the lookup chop, which can output values from a lookup table. So essentially we can provide an index value here from our first input, and then have it pull out values from this table depending on where we are in our index. So we provide a range for that index value in the lookup parameter window here. So we know, or we can expect, that our index will always fall between -1 and 1, and it will automatically map -1 to the left edge of our sample set here, and +1 to the right most points here in our set, and then interpolate between those for anything in between. So essentially, we'll be getting exactly what we see here in chop information. If the note is a higher pitch, we're going to be getting this kind of teal turquoise color. If it is a very low note, it's going to be this dark blue color. Somewhere in between, we're going to get yellow that is shifted potentially in one of those two directions. So let's go ahead and connect the select translate Y to the first input and the top two chop to the second input. In the lookup chop parameters, I'm just going to make sure to set my index range here this lower boundary to -1, because again, our y values are going to be oscillating between -1 and +1 per the math chop we set up before. And now we've got ourselves the color values for each one of those instances that we're generating. Now we're not quite finished here because we have the ability also to manipulate our alpha, our transparency of the color that we're applying. And with the current set of data, nothing is really happening there. So what we can do is to use a second set of chops below to pull in the alpha information from somewhere else and apply it that way. So what I'll do in this case is to grab another select chop, which is going to be accessing our null event operator again. So I'm going to grab the top one here, maybe select index and paste it and move it down just so I don't have to make those connections again. And this time, instead of pulling in our index channel, I want to pull in the ADSR channel instead. So I'm going to delete index from the channel names parameter. I'll set that to ADSR, and then I'm actually going to remove the rename to parameter there altogether and just leave it as ADSR. Then we're going to use the lookup chop again to apply a little bit of easing to this value so that we can kind of adjust when along the ADSR path we start to shift from a fully opaque to fully transparent color that's being applied. So I'm going to add, for that easing, the S-curve chop to the network. And this does exactly what you would think. It creates an S-curve. And we're going to make not a whole lot of changes here, but just a little bit to modify this. We're going to set the prepend value here to 130, which you can see has added a little bit of kind of flat linear moments to, or samples rather, to the beginning of our output. And then we're also going to set on the output range here, we're going to set the maximum to be 0.8, which means that even when we're at the point of fully opaque object, we're going to have a little bit of transparency so we can see through it a little bit. Finally, I'm going to come to the channel page and set this to to just the letter A for alpha, so that in our output we can replace the A channel that we see here with the new A channel that we'll be creating. Finally, I'm going to add another lookup chop. I'll connect the select index to the first input and S-curve to the second input. I'm going to rename this select index to select ADSR, and then we've got our alpha value ready to go. Another handy tool that we have in our toolbox is something called the replace chop. And this is a simple tool that lets us replace a channel coming into the first input with one of the same name in the second input. So if I connect my lookup chop to the first input and then connect my lookup number 2 chop to the second input, we can see we've got RGB values from the first chop and we've got alpha values coming in from the second chop. I'm going to add a null to the end, and this is going to be our null color chop. We can then connect this to our geocomp as well to add color to our instances. And so we're going to come to the instance 2 page and then scroll down. Well, actually, we don't have to scroll on my screen resolution, but let's come down to the color mode section. I'm going to click and drag the null color operator onto the color op parameter, and then I'm going to pull in the red, green, blue, and alpha channels from that operator. Another thing that I want to do here is to ensure that we leave this pre-multiply by alpha in shader option as it is, because our fade out will look a little bit different otherwise. Now, it can be kind of hard to see what's going on in the output here because we have a transparent background. So it can be a handy shortcut to get around this can be to open this in a external viewer by right-clicking on it and hitting View, where you'll then have a black background, which gives us a little bit of a different look. Or we can do something like add in a solid background by connecting a constant top rather to it, and then setting on the output page the operation here to under. Now we've got a white background, which maybe is not quite the look that we're going for. So I'm going to set this color parameter to a dark gray color, I guess, for this example. And then if we view that, we can see we've got a little bit more visible version of the animation. The final step of this project is to create rotation values for each one of the instances. So we're going to be using a very similar kind of setup to this section we used for the alpha, in that we're going to be accessing the ADSR envelope again and using an S-curve to apply this sort of interpolation to it. So I'm going to copy and paste these operators below to use that as the starting point for this part of the project. In the S-curve that we've added here, I'm going to actually reset this to the default state because we don't need this prepend or the name to be alpha in this case. So I'm going to right click on that and hit reset all parameters to set things back to their default state. The lookup chop and the select chop here are fine as is. And then we're going to use some simple math in the math chop to create new X, Y, and Z rotation values. So I'm going to go ahead and copy and paste this math chop. So we have a total of 3. And then I'm going to rename these to math X, math Y, and math Z so that we know which channels we're working on. For this first one, I'm going to come to the output, or the range page rather, and use the toRange parameter here to modify the output. Instead of this falling in between 0 and 1, I want this to fall between 0 and 180 instead. For the Y rotation value, I'm going to come to the range page again, and I'm going to change the range output here to fall between -90 and 0. For the Z axis, I'm going to do something similar. I'm going to head to the range page, and this time I'm going to set the minimum value to 90 and the maximum value to 0. This is going to have the effect in this case of kind of reversing the orientation of those values, but that'll look better for the final rotation. I'm going to use the merge chop again to bring all of these channels together into a single chop. And then I'm going to use a handy chop called the rename chop to apply more logical names to this than channel 1, 2, and 3. I can use something called pattern matching here to automatically do the renaming without having to type in all of the individual names. So I'm going to call these RX, RY, and RZ for rotation in each one of those axes. And I'm going to start by typing in R, and then within a set of brackets, I'm going to type in X, Y, Z, which is going to utilize each one of these characters independently on each one of those channels. Great, so that's it for our rotation values. I'm going to then add a null to the end, and we'll call this null rotate. Then let's head back up to our Go1 operator at the top, and we're going to head back to the instance page, and we'll drag null rotate onto the rotate op parameter. We'll grab the RX, RY, and RZ channels, and if we then take a look at the output, we should see that we have something that looks pretty similar to what we had at the beginning of the video. Now, the main difference here, of course, is that the sequence I'm playing might be a little bit different, but one other thing that I wanted to show you is that besides working with the ramp top that we had set up previously, we can also adjust the lighting that we've applied to the scene in order for things to look a little bit different. So I can come up to this light comp, for example, and set the light to be brighter by increasing this to a value of 2, and that'll brighten things up and change the color as well. You could also tint the light that you're applying to kind of shift things around that way if you like. Now, one thing that you might have noticed if you're paying close attention is that although our boxes are kind of fading to transparency, it looks a little bit less like we have a transparent box and more like we have a texture that is being sort of faded out to complete transparency instead. That is, we can't actually see through the box in any sort of way like you might with something made out of plastic. So that is because we missed a step way back when we added the Phong to our network. If we come to the common page after clicking on the Phong, you'll see that we have this blending transparency option, which we can turn on. As soon as we do that, we should see that we have boxes that now we can see through slightly. So that's just a stylistic choice there, but I thought I would add that in case you were hoping to get exactly the same results as we had at the beginning. So now that you've got this all set up, it's time to explore. First thing I'd recommend taking a look at, if you're still playing the default sequence, is that adjusting the length of the loops will change, first of all, the number of instances as well as the spacing between those instances automatically. I'm going to take things back to the step page for a second and just generate some new steps so that we can see things changing here, and then we can take it back to the loop page and maybe reduce the number of steps and see that we then spread things apart a little bit more. So that's it for this video. I hope you've had fun putting this project together and that it's been a good introduction how you can start to utilize the aspects of the norns that can be transmitted over OSC, and then how you can start to utilize those in programs like TouchDesigner to create interesting animations. Instancing, which we've covered here, is a huge topic and something that you can really take a lot further than what we've done. But hopefully this has given you a good taste of what you can do and gets you excited for further experimentation. As always, make sure that you like this video and subscribe to my YouTube channel and hit the little bell icon so that you can get notifications when I post new content. If you'd like to, you can also follow me on Instagram at JackDelora, where I'll be posting about new videos that I'm working on, as well as experiments and other things along the way. Thanks so much for watching. Looking forward to seeing you in the next video.